All right, factoring special cases for the second time. The first time I got all the way through the end and realized I didn't push the record button. I didn't push start. I had opened the record, but I didn't push start. All right, so remember back when we found the product of x plus 3 squared, I told you write it out twice. Always write it out twice, and then we factored, we found the product by doing like this, x squared plus 3x there, plus another 3x, or two 3x's, and then plus 3x, 3 times 3, which is 3 squared, or x squared plus 6x plus 9. Now we're going to work in reverse and factor trinomials that are in that format, ax squared plus b, 2ab's plus b squared. These are called perfect square trinomials because the result is squaring of a binomial. So in other words, it was x plus 3, that whole quantity squared, that's a binomial squared. You can recognize them. If you do it, you can recognize them. You can use a shortcut for factoring. And how do you recognize that they're perfect squares? First of all, the first and the last terms have to be perfect square numbers. So those are things that like are 1, because 1 times 1, or 1 squared is 1. 4, because 2 times 2, or 2 squared is 4. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, so on and on and on. And then you also notice that there's going to be a middle term, and it's twice the product of the square root of the first term and the square root of the last term, or the b up there. So moving on. So here's the general key concept for factoring perfect trinomials, and let's try a few. So in this case, first of all, are these perfect squares? Yeah. There's a 1 in front of that x squared, but 1 and 9, those are perfect squares. Or x squared is a perfect square, and 9. So remember it said it should factor into, so I'm looking right here, this top one. It said it will factor into a plus b and another a plus b, or just a plus b squared. So it'd be a, which is x, plus 3 squared. And remember, this is really x squared plus 6x plus 3 squared. And I said that the way you can check it is if the second term is the square root of the first thing times the square root of the last thing times 2. And this is 2 times x times 3, which is 6x. So that is what the middle ended up being. So I know that that would factor into, like I said, x plus 3 quantity squared. Now if I look at this one, this is really x squared plus 8x plus 4 squared. And is this middle term made up of the square root of that, which is x, 2 times the square root of that, which is x, times the square root of that, which is 4. And 2 times x times 4 is 8x, so that is true. So I know it's going to factor into the square root of the first term, plus, because these are both plus, the square root of the second term, and then squared. Or square root of the last term and then squared. And this one again, I look at the first thing and the third thing. They're both perfect squares. The middle one is 2 times the square root of the first one times the square root of the last thing. So 2 times 7 times x, which is 14x. So that is true. So I know it's going to factor in to be x. But look at this. The difference here than the ones on the first page is there's a minus in between. So remember we had this rule that this tells us both signs are the same. And how I know that is because to multiply together and get a positive number, either they both have to be negative numbers or they both have to be positive. If they're one of each, you're going to have a negative number. And this tells me what the sign is, or what the signs are. And so in this case, they're both going to be negative. So we still have the x and the 7, the square root of the first thing and the square root of the last thing. But now I need x minus 7 times x minus 7, which we will write as x minus 7 quantity squared. And same with this one. This tells me the same, the signs are the same. This tells me they're both negative. So square root of the first thing minus the square root of the last thing, quantity squared. Now, if you weren't sure, you could go back to the way that we did things before, where we did this and we put a x squared in the first thing and a 64 in the second thing, and we needed things that multiplied together to give me 64x squared, but added up to give me negative 16x, and you would have come up with negative 8x and negative 8x. So 8x, negative 8x, you can put an x here, x there, minus 8, and you would have still gotten x minus 8 squared. So if you can't do it the new way, it's okay, you can still do them. You're just going to do them the other way. All right, here we have numbers in front of that x squared. That's okay. First I look to see if they are perfect squares or if I can factor anything out. These two happen to be perfect squares, 4 and 9. There also is no common factors between 4 and 9. But if they're perfect squares, and is it 2 times 2x times 3 that makes up the middle terms? So 2 times 2x times 3. 2 times 2 is 4 times 3 is 12, so 12x is the middle term. So I just know square root of the first thing. So square root of 4x squared is 2x. Both the signs the same, both are positive, so plus square root of the last thing. And I have to square the whole quantity. Same with this one. Are the middle terms 2 times the square root of the first thing times the square root of the last thing. And 9 times 4 is 36 times 2 is 72, so that is right. So, but this is, both signs are the same. They're both negative. So I start with the square root of the first thing minus the square root of the last thing. So this quantity squared would be my answer. And again, you can always check your answers too. If you put those on the outside of the box and fill the box in to do it, to work backwards and check your answer. So if you did 4x minus 9, 4x minus 9, you would get 16x squared here. You get minus 36x there. You'd get 81 here, and you would get minus 36x here. Combine these two, 36 and 36 is 72. So we do end up with the right answer. That's just a way to double check. All right, remember when we had things that look like a plus b and a minus b, and you had to multiply together to find the product? The middle term of those things just disappeared. They fell away or canceled each other out. And you ended up with the first thing squared minus the second thing squared. Now we're going to work backwards and figure out how to factor things that are in that form. So what I was saying before when we multiplied them out, so if we had like x plus 6 and x minus 6, and we foiled them out, or we put them on the outside of the box and multiplied, however you like to do it, you would get x squared in the top, you'd get 6x down below, we get minus 36 here, and here we get minus 6. Well, those two cancel out, and we would have gotten x squared minus 36. So those are the kind of things that we're talking about. How do we recognize them? We recognize them by, you're starting it with binomial. So you're only going to have two things in your expression. So two parts to the expression, two terms. It will have a subtraction between it. It doesn't work if there's two terms with an addition in between. That doesn't work. It has to be subtraction. And then both the a number and the b number have to be perfect squares or it won't work. So here's some examples. This is a perfect square. That is a perfect square. I don't have any middle terms. So it would be the square root of the first thing Again, it has to be a minus the square root of the last thing. And the square root of the first thing plus the square root of the last thing. It's always going to have one term that's one factor that's a plus and one that's a minus. This one, x plus the square root of the last thing, x minus the square root of the last thing. Here, x plus the square root of the last thing, x minus the square root of the last thing. And again, you can write multiplication in any order. So it can be plus and then the minus, or the minus and then the plus. That doesn't matter. All right, what do we do if there's a number in front of x squared? Well, if they're both perfect squares, you still treat it the same way. 49 is at 7 squared. 100 is, it's 10 squared. So it's going to be, one's going to be plus, one's going to be minus. Square root of the first thing is 7x. Square root of the last thing is 10. Square root of the first thing, square root of the last thing. This one too, both terms are perfect squares. Square roots are 3 and 2, so it would be 3x plus 2 and 3x minus 2. We can double check to make sure the middle terms cancel out. There's 6x in the middle, and there's negative 6x. So those two would cancel each other out. Here, if you look, 24 is not a perfect square, and neither is 6. So am I stuck? Can I do anything? Well, yeah, because 24 and 6 both have a common factor of 6. So first I'm going to start by factoring 6 out. 6 times 4 is 24, so it would be 4x squared minus 1, because 6 divided by 6 is 1. Excuse me. Now I look, because can I keep going? Are those both perfect squares? Well, they are. So I can factor them. Remember, my middle terms are going to disappear, so I know I'm going to have two factors. One's going to be a plus, one's going to be a minus, and then square root of both of the things. So square root of 4 is 2x, square root of 1 is 1. So this is the factored form. It's going to have all three of those parts when I go to factor it. And for the second one, again, I look at this and I see those aren't perfect squares, but can I factor something out? And 12 goes into both of them. And I get x squared minus 4. And so that 12 has to come down with us. And x squared minus 4 is square root of the first thing plus the square root of the last thing. And then square root of the first thing minus the square root of the last thing. So that's that one in its factored form. And then last but not least, I'm going to work down here a little ways. I'm going to look again. Oh, this one has a middle term, so I know it's not going to be a plus minus 1. It has two terms. Both of them are going to have the same sign. Both of them are going to be positive. First of all, those are big numbers. I'm going to try to factor something out. Well, I know 3 can go in all of it. So first step, I would factor out a 3, and I would have 4x squared plus 4x plus 1. Now I look, these are perfect squares, and the middle is made up of that 2 times the square root of the first thing times the square root of the second thing, or 4x. So then I know that it's going to factor into being 3 square root of the first thing plus the square root of the last thing, those quantities squared. So that's my factored form. 3 times the quantity 2x plus 1 squared. And that is all for today.